Welcome to AI for Good, the leading action-oriented global and inclusive United Nations platform on AI. Organized by ITU in partnership with 40 UN sister organizations and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end, as we will hold a 30-minute networking session in the neural network. Here you can meet, ask questions to our distinguished speakers, connect, and chat with the AI for Good community. It is now time to kick off the session and welcome our first speaker. The floor is yours.
I thank you very much, Anna, and good day all. My name is Andrea Manara from the International Telecommunication Union, ITU, and I will be moderating today's session. We are very pleased to launch today the new GeoAI Discovery channel on the applications of Geospatial AI, GeoAI for short, and the relevance of GeoAI to the Sustainable Development Goals. GeoAI is the scientific discipline at the intersection of geospatial data and artificial intelligence. Geospatial data is data with a location component. A large part of existing data has a location component. Geospatial datasets are more than just data taken with satellites or planes or drones. Geospatial datasets can include also social media data, data from your mobile phone, or data from IoT applications. Behind the rise of geospatial AI are three trends: the increased availability of geospatial data, the advancement in machine learning, and the availability of massive computational power. This introductory section will be composed by 4 parts: a panel discussion to kickstart the series by discussing its objective and relevance, and the benefits to the global community by accelerating the outreach and impact of GeoAI. A tech talk on what it will take for AI to work with geospatial data, and the Q&A session. If you have any question, please submit them in the chat of the neural network platform. These 3 parts will last 1 hour. Finally, a 30-minute networking event will be hosted on the AI for Good neural network platform. This will be the opportunity for the audience to interact with each other and to build connections and ask the panelists for the questions. Geospatial data are one of the key enablers of the information and communication sector. And as the United Nations Agency for ICT, ITU wants to make sure that the role and the potential of geospatial data in GeoAI for the development of ICT infrastructures, systems, and applications is well understood. Just to give an example, very accurate geospatial data are essential for 5G network deployment, which would require denser telecommunication networks, more base stations placed selectively and strategically when implemented in the millimeter wave bands. Indeed, both accurate geographical data and advanced spatial analytics are essential to ensure that these 5G radio networks are cost-effective and efficient. It is really my pleasure now to welcome our distinguished panelists, who are also the 3 curators of this series. Nadine Alameh, the Chief Executive Officer of the Open Geospatial Consortium, OGC. Maria Brovelli. Hello, Nadine. Maria Brovelli, Professor of Geographic Information Systems and Digital Mapping, Politecnico di Milano, and Chair of the UN GGIM Academic Network. Maria, if you can switch on the camera. And Barbara Ryan, Executive Director of the World Geospatial Industry Council, WGIC. Nadine, Maria, and Barbara, each of your respective organizations play a very important role in the GeoAI ecosystem. I would start with Nadine. What areas of standardization and interoperability are we looking at in OGC to support the use of GeoAI for good?
So first of all, good morning, good evening, everyone. Thank you, Andrea, and thank you, ITU, for hosting this event. I want to start actually by saying how happy I am to be here alongside Maria and Barbara to kick off this very timely series on GeoAI for good. And I'd like also to start by saying that I feel this responsibility, being the CEO of the Open Geospatial Consortium, that I'm actually standing here representing a whole community of global geospatial experts who energize me every day because they are collective problem solvers and they're genuinely trying to do good. We're trying to do good by helping others get value from geospatial data, to go from data to decisions, to insights, to impacts. And what our part is to make sure that the data, the processes interoperate via standards and best practices. And back to your question, I think along the chain of this from data to impacts bubbled up GeoAI, for feature extraction, for imagery classification, for segmentation, for even, autonomous driving vehicles and interpretation of the environment around it. The use cases just kept coming in the geospatial community. And I feel mostly driven by this trying to make sense of this otherwise crazy amount of remotely sensed imagery and moving features. And then the domains kept expanding. And then we started to see more startups actually base their business models on GeoAI. So we said, okay, we need to create a GeoAI working group in OGC. And that happened in 2019. And I mentioned this because think about it, 2019 is not a long time ago. This whole thing is very new. And I think that's why this collaboration, ITU, UNGGIM, academic network, WGIC is so timely. So again, to your question, at OGC, we're trying to make sure that the data is ready for GeoAI, and you'll hear Lokendra talk about it later today. We're trying to make sure that the data is fair, findable, accessible, interoperable, reusable, including the training data. So we want to ensure that the training data is properly documented so that the outcomes can be trusted. You'll be hearing a lot about trust when we talk about GeoAI. We want to make sure that the processes can actually be validated again so that the outcomes can be trusted and the whole chain can be repeated and scaled. And we're trying to make sure this has nothing to do with standards, but I think I have to say it. We're trying to make sure as technical innovators, because that's exactly what GeoAI is, we're trying to do it in an ethical way. So we're developing or trying to develop with the community a strong foundation for open standards for GeoAI sample data. We're trying to support the creation of open tools and frameworks. And we're here to try to encourage open best practices for, again, I'll say it, ethical use of GeoAI. And I feel this series covers all of that and more, and none of us can do it alone. So I'm, again, just really happy to be here, and I'm happy to answer any questions later to dig into the details of the actual standards and activities we're doing at OGC. Thank you again, Andrea and ITU.
I thank you very much, Nadine. It's really a pleasure to have you here and one of the curator of this series. It's really a pleasure. I will now move on to Maria. Maria, so we see that machine learning is really emerging in an important way in many areas linked to geographical information. I'd like to ask you how these issues is addressed in universities.
Okay, thank you. Thank you so much for this question, Andrea. And I want also to say good morning, good afternoon to everyone. I'm very happy of being here. Thank you, Andrea, for sharing. Thank you, ITU for organizing. And I'm double happy because you decided to have 3 curators that are 3 ladies. And in the world of geospatial information, traditionally it was not such. If we think about cartography many years ago, it was not such. And also AI is not such. So it's something very good and very appreciated, this choice of having 3 ladies here. So I'm very happy about that. Thank you. Then I don't want to repeat other things that Nadine already underlined, but try to answer to your question specifically with respect to the university. I have to tell you that in the universities in general, there is a huge interest about this topic, even if it is not a uniform situation, because we have universities where these topics are already taught, and we have many universities which are just in the beginning of these travels. So I believe that with respect to this point, is a series or these kind of events that we are organizing are very important for students, but also for the colleagues at university. Also because our idea is to propose something that is very various. So going from the conceptualization of GeoAI to the very basic training. So workshops where we will teach about how it is possible to do something using tools related to machine learning and deep learning. And so this, I believe that this kind of richness is very good also for different typologies of possible attendees to this forum. And speaking about the topics, I believe that GeoAI is really something new. So it's not simply AI with the coordinates, for at least for 2 reasons. If we think about the models, because in the end, AI, if we want to summarize, are models and training data. Those are the 2 parts of AI. And with respect to the models, in my opinion, obviously, if we want not to use simply black boxes, but we want to better understand what we are using, we need to go toward what is called as the physics-based, or we can say geographically based machine learning, which is something new that we have to invent. But the geospatial contextualization is not just something added. It has to be really the fundamental of thinking about how to use these new tools made available. And on the other side, if we think about data, as Nadine said, it's really important to have good quality data. And it is really important to propose a sort of data-centric AI, where these data are geospatial data. As, so again, you see that this geo is not just something less important than AI, but we are really starting something new, both with respect to the data, because we know that geodata are spatial, and also with respect to the models. We want to have something that is geographically based and not simply black boxes. Okay, thank you.
Thank you very much, Maria, for these nice insights. And I like now to move to Barbara. You're organization has written a very interesting report on GeoAI, which was launched last year in ITU. What I want to ask you, which are the next steps for a larger adoption of the best practice which were identified in your report?
Well, thank you, Andrea, very much. And listen, let me add my appreciation to ITU and the team there, Andrea, you and Reinhard. One, it was a great idea to hold an entire series like this, and I can tell you that there are no two people that I would rather be working with Maria and Nadine on a cohort for this. So thanks very much for reaching out to us. And it's funny because even in Nadine's opening remarks, she talked about the ethical use of AI, and later on in the series, there'll be an entire dedicated session just to the ethical use. So I think what you're going to see in this entire series is that some of the challenges that are going to be presented today, we will try to address in a dedicated series on those topics. But Andrea, thanks for mentioning the report, because actually it was Lokendra Chauhan who was our lead investigator on that report. And so you will all be hearing from him laying out the whole framework for geospatial AI. But we did launch it. And so for us, using ITU and collaborating with ITU brought way more visibility to the topic than I think we could have achieved alone. And certainly in partnership with Maria's university and the UNGGIM and Nadine at OGC, will these consortiums of other entities will be a force multiplier to get this topic out. And so that's just really important collaboration among universities, the public sector and the private sector. And then I guess I just will say, to be clear, we, the World Geospatial Industry Council, are a not-for-profit organization, but you must be a private sector company working in geospatial or Earth observations to join WGIC. And, you know, we're seeing just increased attention in this subject. It's, you know, the estimates in 2021 were about a $450 billion industry. And I think particularly your opening videos that just talked about what this can do for the Sustainable Development Goals is so important, because we've got to leverage not only those public sector assets, but the work that's being done in the private sector. And so we in WGIC feel very fortunate to be representing the private sector contributions to this whole topic. And it needs more socialization through efforts like this and through stronger public-private partnerships as well. So thank you very much. And I'm really looking forward to not only today's session, but the entire series. So thanks again to ITU.
I thank you very much, Barbara, for your intervention. I would say to move now to the technical talk, and then we leave some time for additional Q&A. I'm pleased, really pleased now to introduce Lokendra Chauhan. Lokendra is the founder and chief executive officer of Qen Labs Inc. and lead author, as Barbara mentioned already, of the recently released GeoAI report on geospatial applications and policies. Lokendra will make a tech talk on what it will take for AI to work with geospatial data. Lokendra, the floor is yours.
Hi. Thank you, Andrea, and thank you, Maria, Nadine, and Barbara, for giving me this opportunity. Let me just put my slides up first. Hi, do you guys see the slides?
Yeah, everything's fine.
Oh, okay, sounds good. Cool. So thank you. Thank you again for inviting me for this talk. Now, I'm Lokendra Chauhan, and I'll be talking about how do we make AI algorithms work with geospatial data. So I won't be getting into highly technical topics as Nadine was getting into, but I'll be definitely repeating a lot of what Andrea mentioned in the beginning about geospatial data and this what makes geospatial special, which Maria was talking about earlier. So I'll give a quick overview of the space and then talk a little bit about why geospatial is different and then get into examples. Yeah. Okay. So hi. So first things first, I just wanted to make some acknowledgements. Obviously, Barbara talked about the Geospatial AI report. So there's a lot which I present here is something which I learned during the process of writing that report. And then there are a lot of other examples which come from the work done by my collaborators at these different research institutes and universities, basically. Now, the word geo means earth, and hence the geospatial computing comprises of, as Andrea was talking about, multidisciplinary ideas and technologies that help us understand and navigate the physical world we live in, or communicate our relationships with the real places on Earth. Now, so this is why the problems addressed in geospatial domain cover most of the important challenges facing humankind on our planet. And a good and holistic starting point is to look at sustainable development goals and how GeoAI or geospatial computing relates to them. Now, so there was a study which came out from Group on Earth Observations a few years back, and they had listed that out of 13 out of 17 SDGs have one or more indicators that could be measured using Earth observation data. And Earth observation data is just one kind of geospatial data. Now, as Andrea already mentioned, so in geospatial world, we have this famous saying, everything happens somewhere. So as soon as you take into account the component of where or location, every piece of data becomes geospatial. This includes satellite or any of the data which overhead imagery, whether through aircrafts or drone. Then traditionally we have had surveying data, points of interest data, or the governments and enterprises have a lot of data records of their own about different locations of their business. Then IoT data has been growing like anything, but as Andrea mentioned, one of the biggest and fastest growing segment of geospatial data is the user-generated content, and that's because of the cell phones, etc., which we own. This includes GPS traces, geotag medias, or when you write a review of your favorite restaurant or you talk about a particular location on social media. In fact, I'm sure a lot of you might have even used COVID tracing apps in the recent past, which use Bluetooth functionalities and all. So it's just geospatial data is everywhere. And yeah, you have data on, you can go below ground and on water surfaces also. But so that's an overview of what all is included in geospatial data. Next is how do you, I just wanted to classify geospatial users. So traditionally, there's been a big tradition of expert level users of geospatial technology, especially in defense or space agencies, even in supply chains and logistics, or some other map enabled, wherever you required any kind of map enabled analysis. And often these are academic researchers or product managers at companies trying to build products. Then another class of users has been analysts who are using these products. But more recently, what has happened, the largest and the most recent group of geospatial users is anyone with a smartphone or PC. Now, these users have fast evolving expectations of all new technologies. And as product developers, I would say that we must hide all the complexities while giving users the answers they seek in a simple format which they are accustomed to, like querying Google or calling a cab from Uber, etc. So there's a lot of, the user expectation is quite about near real-time responses. And this cannot happen independently. You require a lot of so back on the back side, there's a lot which will go on, which includes making sure that you use data ethically and all. So next, like I just wanted to briefly touch on the trends in GeoAI. So what we see right now is a lot of applications in GeoAI are more of descriptive nature currently. So what I mean is, let's say if you're looking at a satellite image, then you're looking, you want to identify whether you're seeing a farm or a road or a building. And let's say if you compare multiple images, then you're even able to detect changes like how new buildings popped up, etc. Similarly, but over the time, like what we are expecting, and now pilots have started popping up anyway, but in next 2 years or so, we expect a lot of predictive use cases coming up. What I mean by it is, let's say, being able to predict how much of crop damage one can expect based on the weather conditions or some other changes, or what kind of damage costs can be expected in terms of different road assets the government has. And from this also, the expectation is that moving forward, we'll move towards use cases which will become very prescriptive in nature, where the systems, so AI systems will be, or GeoAI systems will be able to give you highly specific actionable recommendations, like, okay, in your farm, you need to use this particular pesticide to be able to avoid the potential crop damage which is about to come because of the conditions. So for a delivery company or logistics company, okay, you may have to move these vehicles from your fleets from point A to point B to be able to make sure that you meet with demand in by tomorrow or whatever. And all this is being enabled by the big trends in data, which I already talked about, which is the quality and quantity of data in geospatial has been increasing like anything. And at the same time, the cost of data acquisition has been falling like crazy. So these are like the broader trends in geospatial space. Now I'll get to the idea which I think Maria was trying to talk about, which is so broadly, and this is important because neural networks or AI, as we know right now, the deep learning models are mostly based on neural networks, based on brain. Now, there's another concept of embodied intelligence. Now, we all know that brain is very important, but that's not the whole story. I'm like, if we try to really introspect about how we really learn or how our brains work, we soon realize that we are constantly adjusting to our to continuous feedback that our bodies give us based on our surroundings. And if you want to be, so basically, we are learning through our interaction with the space around us. And if AI has to become usable in real world scenarios, or much more usable in the real world scenarios, then it's vital for it to be able to make sense of information and feedback received in space and time. And that's exactly what the whole discipline of geospatial sciences has been about. Now, I'll just show you, okay, so here's about like what makes geospatial different. Now, so this is a map of Europe, R&D intensity in Europe, which is like R&D expenses divided by GDP. And what you see is like often the color changes are not drastic. So like this is another map of the US, like heart death rates based because of heart diseases. And what you notice is basically the colors are not changing suddenly. And that's that phenomenon. That phenomena can be described in geography because there's something called first law of geography, which says that nearby things are similar, more similar than things which are far away. And broad idea is that this is basically a fundamental principle in spatial data science, that soil, water, atmospheric elements, or even cultural artifacts like architecture, language, cuisine, people's lifestyles, they don't change suddenly in space and time. Their continuity is maintained. Basically, no sudden transitions, and that's what makes a lot of geospatial data very different, because this phenomenon is called a spatial autocorrelation, and most AI algorithms work on an assumption called IID, which is that all their data is independent of each other and belongs to identical distributions. But this assumption gets violated by spatial data. So so if you have so when you have data which has spatial autocorrelation and violates this, then you need very different kind of conceptual models, as Maria was trying to hint at, for querying it or analyzing it. And like, let's say if you're talking about sorting geospatial data, sorting location data, you just can't sort it in the ascending or descending order. Like, let's say if you do it by latitude, then you'll find that Orlando in Florida is closer to New Delhi than to Miami. Whereas if you do it by longitude, you'll find New York is closer to Bogota in Colombia than Chicago. And that's not the case. And you can find spillovers of such the geographic elements, relationships into other kinds of data also. And like I can clearly say that most AI algorithms won't be able to figure it out. But if you see a name like Jamil Chi or Caleb Singh or Joao Khan, they are highly unlikely to exist ever, because the combination of surnames and first names are from very different locations, far away, and usually there's not much of interaction. Even like geospatial data also includes temporal data, and that has its own complications. So basically, what you need is very specialized methods for solving geospatial problems. Often it includes trying to identify frequency patterns or doing spatiotemporal clustering, etc. And or even trying to identify which things occur together, like co-location, or which don't occur together, etc. So moving. So I'll move on to the next. Like, I'll give you an example of this. Let's say if I ask you a question of what is the distance between Geneva and Switzerland, the simple answer is 0, because Geneva is inside Switzerland. But if you ask the biggest AI company on the planet, Google, you get an answer which makes you travel 3 hours, and that's somewhat nonsensical. Similar, what is the distance between France and Germany? These are 2 countries. I mean, you know that answer is 0 because they are bordering nations. You can say it's an invalid question because distance should be between 2 points. But that's not the case when you ask Google Maps. So that's what I mean, that why do you need to treat location data or geospatial data differently? It's a different beast, and it has to be dealt. You need very specialized methods to work with that, and that's why AI also has to adapt. Here's another example. Like, okay, some of my colleagues created and trained a neural network model to identify places that are similar using satellite data and maps, and then looked at sparsely available accident stats to predict where more accidents can happen in future. And they trained the data model for data till 2 years back only, and then they looked at what happened in the next 2 years, and their model was model actually gave very good results. So it's like, but then the main idea was like, okay, similar places was gonna go behave similarly, and that's not how typical AI algorithms would have worked. Anyway, here's another question. So let's say if I ask anyone which of these 2 images is snow, it could be confusing for even humans. So just imagine how hard it would be for machines. And like their accuracy is going to go down like anything. But to any human, if you tell where these images were taken, let's say if I tell you the one on the left was taken in Finland, whereas the one on the right was taken from Rann of Kutch in India, which is a very famous salt bed, then you know that the image from Finland is of snow. But right now, AI models are not able to incorporate that kind of geographical context. In fact, there was another aspect of geospatial data, like we in the geospatial discipline, we use the whole electromagnetic spectrum. So let's say, if I even provide you infrared images instead of these 2, then you will know that the image which shows colder temperatures is snow. So that's there. Some of my colleagues had actually built a specialized neural networks which takes into account the spatial variability. Similarly, now, and speaking of the electromagnetic spectrum, this is another example. So in 2019, during Consumer Electronics Show, which is held in Las Vegas every year, most of the autonomous car companies were there to showcase their AI-driven cars. Unfortunately, it ended up raining heavily, and all these companies except one, named Ada Sky, had to keep their vehicles parked. Now, what happened was Ada Sky was using thermal imaging sensors that could detect people hundreds of feet away during the downpour. In fact, the thermal sensors were also able to detect people dressed in white and standing against white backgrounds during heavy rain. So that's a somewhat like how do you use different kinds of data which geospatial people in geospatial domain have been using. Now, so in fact, this brings me to the question. So main point here is that the standard AI algorithms for computer vision use only a small fraction of the data available for analysis in geospatial domain. Geospatial folks have been using the whole electromagnetic spectrum. Therefore, building AI algorithms that can capture the richness of information provided by the entire electromagnetic spectrum will enrich the field of AI itself. Like leveraging all forms of geospatial or multimodal data is a way of augmenting the perceptual capacity of AI algorithms. I'll come to another example. This is also interesting. So let's say so this is about crime data analysis and how the clustering can happen. So let's say if you're trying to analyze crime data and you want to identify where the perpetrators might be from. Now then, in geospatial field, what you try to use is a ring pattern rather than a typical cluster. And most of the AI algorithms are not successful at bringing out the ring-shaped clusters. And why ring-shaped clusters is because most often criminals or serial offenders won't do crimes in their immediate neighborhood. They usually travel a bit far and then do the crime. And then they also come back. So they don't go very far because they need to be able to come back to their safe zone. And that's why you end up noticing a ring-shaped pattern. And now that's a geospatial idea. People in the geospatial world has been using these ideas to identify potential sources of crime, or let's say home of a serial criminal kind of thing. But that, so there's just a different way of thinking. That's what I want to talk. Here's another form of crime data analysis. Let's say you are observing issues like pedestrian fatality or some other kind of crimes, and the goal here is to identify shortest paths for sending police patrols. Now, use any other AI algorithms and try to do any kind of clustering, you'll get all these ellipses or circles, in which like you have to cover a very different area and very complex routing recommendations will come up. But what you need to be able to do is to cluster these crimes on different road routes or linear way fashion. And that's something which doesn't happen in case of regular AI algorithms. Now, here's another idea, which is, let's say if you're looking at an image of a person or in a scene, you can identify the hand or head or legs differently, or maybe a car or its windshield and tires, but you cannot swap them around randomly. Whereas, because that will become very nonsensical picture. Whereas if you have a satellite imagery, in effect, to some extent, it doesn't matter where you move one building from one place to another, or swap it to the farm, because it still is a scene. It's not exactly the same scene, but what it allows is that a lot of different analysis can be done at a much faster rate if you try to treat it as a network of those entities, and because then you don't have to analyze all pixels every time. So this is like a different benefit of taking geospatial data of a particular kind. Here's like another algorithm I want to show. Like, so we had done this work, and so the first part in the blue, what you're seeing is we're using GPS traces from different people's phones to create a map of location in Qatar, Doha, and then we use another algorithm which is acting almost like, see, you put an individual on any crossing of road and ask them to iteratively figure out where the roads move, and that's how it was doing. So basically, it was trying to come out with direct vectors, directions also, hence being able to create road vectors directly instead of first identifying each pixel, whether that's a road, and then trying to come out with road vectors through some post-processing. Now, we used this previous algorithm to be able to build accurate maps in Timor-Leste, which is a small country near Indonesia. And once you have accurate maps, then we can tackle more complex problems like where to put the next health facility. And there again, like the analysis has to be done in a different way, because we're talking about it's a different sort of, because we have geospatial data and the answers change very differently, whether you're looking for people to have access within 2 kilometers, increase the access for people who want access within 2 kilometers, or increase access for people within 5-kilometer range. Anyway. So these are different kind of problems which people in geospatial world work with. Here's an idea. It's not a existing system, but we recently proposed this one somewhere. The idea was that how do we use social media data during times of disaster? So broadly, like you capture social media data, try to classify it fast into whether someone is asking it's a need, whether what is the urgency level, are they talking about some resource information, and then also do geoparsing, which is basically identify where exactly the tweet or Facebook post or even SMS came from, and then basically finally present it very fast in a format where first responders can actually act on that information. So I think that's the main objective. Here's like another thing which everybody is talking about: carbon credits and carbon markets. Now, right now, we can use hyperspectral imagery to measure soil health characteristics, especially soil organic carbon matter, and enable. If you can do that, then that can enable calculating and verifying carbon credits a farmer can sell for additional income. So that's another use case. Similarly, we have a use case like I'm sure like a lot of people would have heard of Western cities using satellite imagery for calculating property tax violations, and that's so that's a growing use case in the West anyway. But World Bank also did a study in which they tried to do the same thing in case of Kenya. So this is an image from Kigali in Kenya, and World Bank was able to roughly calculate the potential of property tax, and also and hence the authorities could act. So it's all in all I want to say, like, there are lots of use cases in geospatial, but you need to treat the geospatial data very differently. You just cannot use the same methods which were used traditionally, which are used traditionally in computer vision or NLP, which are the primary domains on which AI algorithms work. In case of geospatial data, simple problems itself change. Like, just to know, like as I was talking about sorting, so that itself is different. Like, you might want to sort things by nearness or area size, or maybe the length of border shared between two countries or cities. When we come to use cases, like, yeah, we talked about, I think, use cases in different kind of segments. You can even, government has its own different kind of use cases, whether that's through land use classification, even as asset tracking and management, and that's useful for industry also. Similarly, a lot of use cases in agriculture and related to environment. In fact, one of the interesting use cases some of my friends are working on is not just water body monitoring. So you can observe the shape, the size of a water body depending on the area you can measure, but you can't calculate volume. So some of my friends are working now on identifying the depth of water bodies using satellite imagery. And that's, they're building models around that. That's a very interesting challenge in itself. I guess I'll stop here, and I guess flows. Yeah, I'm ready for questions if any. So I hope I made some sense to you now.
I thank you very much, Lokendra, for this very, very interesting overview of the situation. Let's see if we have any question in the Q&A. Yes, we have a couple of questions. So, which is your most exciting GeoAI use case? You can answer, Lokendra, or actually I will ask also Maria, Nadine, and Barbara to switch on their camera, because all of these would be for everyone who wants to answer first, please. which is your most exciting GeoAI use case? Who's gonna? I see that Nadine wants to take it.
I don't know if it's exciting. That's why I want to get it out of the way. I wouldn't call it exciting. I would call it very, very useful, since this is AI for good, because we've been doing a lot of work on disaster, mitigation and response and management overall. And the couple, use cases that pop up, as you mentioned, the question are, one, early flood detection, early disaster detection, right? So you identify all the patterns, and you can, ring the bell earlier so you don't get the flood or the landslide or the wildfire. So this is super, super useful anywhere in the world. And the other one, it sounds also simple, but it's very impactful also during disasters. Using GeoAI to automatically detect all the closed roads and all the damaged buildings, so that you can reroute the resources accordingly. So it's exciting because GeoAI helps accelerate our response to disasters and our preparedness. So maybe that's why it's exciting.
Very interesting. Thank you very much. I see that Maria would like to add something.
Yes, I want just to mention that we are going to present how to verify deforestation in one region. So we decided to do this exercise in the Amazonia, but in principle, you can repeat it where you want. And so one of the events of this series is this workshop, where we will teach the people how to compute the deforestation, having simply the computer, nothing else, because they will use the Google Earth Engine platform, and they will use the satellite images that are available for everyone. And therefore, the only thing that they need is to attend the workshop, learn how to do that, and they can repeat it everywhere in the world, in every part of the world where they are interested. And so you see that it's a very powerful tool if you want to do something that before was not possible to imagine. So now we have this possibility of monitoring the situation about the deforestation, simply staying at home, simply using something that is available for everyone. So this is very exciting, in my opinion.
Thank you very much, Maria. I see that we have now many questions that are arriving in the Q&A.
Should I just wanted to add to the small thing which Nadine was mentioning about the disaster response case. So yeah, so that's one of my favorite use cases also. In fact, like I'm doing some work on that where like we can immediately, I can even show you a demo within 20 seconds. Like you get satellite imagery and we'll be able to calculate where the roads, identify where the roads are in an image, not just roads, like road vectors. And that can be used, if there are some errors, those could be edited very fast. And you can have most recent maps immediately available. And we'll be working with Planet Labs on that they'll be providing some satellite imagery soon after disasters. And then we'll provide them those maps which can be used for to read out in case there's a road damage, etc. By the way, there's another area I think Nadine has also done some other events before, which is like which many people might find exciting because of the buzzword around it. Is the whole metaverse angle. I'm like, you're talking about metaverse. You're trying to build an augmented reality on top of the real world. That has to be enabled through the geospatial data itself. There's no other way to do it. Okay, I'll just shut up now.
I thank you very much, Lokendra, for your insights. I have a question. if I want to perform land cover classification using machine learning, how can I prepare data sets using raw satellite images? I'm sure that Maria may want to answer this that question.
Yes, generally training data set are local, so collected in the field, or if you want to use satellite images, you need to use very high resolution satellite images, but then you need to label them, because if they are not labeled, they are useless, as a matter of fact. So preparing a very good training data set for land cover is really a fundamental part of the activity. Yes, and it is not something that can be done automatically. You have to work on that for preparing a good quality, because we know for sure that if the quality of our training data set is not good, okay, we will obtain in the end a map, but how reliable is our map? That is another story. So the most of the data are collected in the field or with high resolution imagery if we want to use satellite data.
I'll add just a little bit to that, Andrea, if you have just
Please.
A couple minutes, because particularly on land cover and land classification, depending on what scale, your effort is going to be in, there's a lot of ongoing effort. So you wouldn't want to just start from scratch, not taking advantage of some of that ongoing work by, major international organizations that are trying to coordinate that entire effort globally. So boy, I'd encourage you, or the person who wrote the question, to kind of look around too on what's been done.
Thank you very much, Barbara. We have a question that is very relevant in this period of pandemic. What's the future for geospatial and public health? Who wants to answer that? Nadine.
I thank you for actually asking the question. Well, the future is almost here, right? I think technically speaking and awareness speaking, because the pandemic has shown that geospatial matters. Geospatial matters when we're locking down areas and what scale of lockdown, how you trace, the spread of a disease, and also at what scale, and also showed the difficulty of integrating data from multiple sources that's all geospatial, whether it's the location of the hospitals or the patients or the supply chain that's getting disrupted because of the pandemic. So I think the future is here. What we need in this case is this mobilization to actually take it seriously and prepare for the next, big event, global event. And with that comes what we're trying to advocate within the OGC community, health spatial data infrastructure. There are a lot of pieces. We know how to do this. I mean, this is, you got the collaborators here, like Barbara said in her opening statement. It's all about collaboration. We need to raise it and make it real. From my perspective, via constant dialogue on the best practices, so we're not reinventing each other's work, and then standards so that the data connects and you can actually use it to create policies and trust it to create these policies for government and everybody.
Yes, you're right. This is really important. Another question, can you please throw some light on biggest use case across industry as per their market size? Who wants to take that?
I think one thing we can say is when you're talking about industry, a lot of use cases are going to be around dynamic routing kind of applications. Let's say when you have a large fleet, how do you manage that fleet in real time? If there's a disaster, some roads are crossed, or maybe if your part of your fleet cannot work because of whatever reason, accident or something else, then how do you manage your operations still? So that's one big use case which definitely comes out from industry. Then the whole carbon credits industry, if this is gonna take off, being able to map from where how much of carbon credits are being generated or how much of emissions are being created, and doing that accounting will involve a lot. But then that industry is very nascent right now. So if you ask like what are the today's biggest use cases, those are usually around navigation and routing. But moving on, they're getting into these use cases for new industries which are getting enabled like now. And one more thing I wanted to add is like even when for whether we talk about public health or any kind of, and someone has even also asked, like, do we need a lot of annotated data sets to be able to benchmark data sets and all? So all that would also see we need to understand that a lot of geospatial knowledge is about people's knowledge about their places. So crowdsourcing that knowledge, like everybody together knows everything, but we don't have it all together. And that's where crowdsourcing would play a big role. There are right now a lot of issues in terms of quality assurance for crowdsourced data, but that's going to be one of the big enablers for any kind of geospatial applications. And you can directly see in terms of OSM, like within 10 years or so, OSM has created a pretty good map of the world, which is being used by, I think most of the companies are using that because you end up paying a lot to Google otherwise. So crowdsourcing is one thing I want to definitely stress on.
Right, very interesting point. I see that Barbara and Nadim may want to take the floor.
Yeah.
To complement
just real quickly, back to that last question. So I'm not sure that I don't have the data, and of that $450 billion, for the global geospatial, how much is AI or machine learning? But I can tell you that in the WGIC report, of the companies that were in fact interviewed for that report, 79%, so nearly 80% of those companies expressed both a high interest and a move towards those tools and technologies, as compared to 5% that was low and only 15 or so, 16% that was medium. So clearly the industry is really interested in this topic.
Nadine?
Yeah, so I'll add, I don't know about the size. So Barbara and WGIC, we refer to them when it goes to, comes to market size. But my initial instinct when I saw the question was the insurance industry. And that's everywhere, right? So I hear a lot of agricultural use cases because their customer is the insurer, as well as disaster and asset, I think, insurance. So that's definitely big. And speaking of big industries, the defense industry, with respect to threat detection at so many levels, it's all geospatial if you think about it. And there's definitely a lot going on in GeoAI in the defense sector. So insurance and defense, I don't know about market sizes, but as instinct response, that's what came up to my mind.
Thank you very much, Nadine. I thank you very much all. I think that is the time now to wrap up the session, and then we can move to the neural network event. So just to wrap up, before giving back the floor to Anna, I like to mention a few future events on the GeoAI Discovery channel that were already mentioned. On February 22nd, we will have the second session of the GeoAI series on ethics and GeoAI. And instead of March 15 and 29, as Maria was mentioned, we have a workshop which is going to be organized in 2 sessions on analyzing the Amazon deforestation with machine learning and the Google Earth engine. As I mentioned, will be organized by Maria with one of her PhD students, and we really hope it will generate as much interest as the past event on satellite data analysis and machine learning classification with QGIS, which had gathered thousands of participants. I also would like to mention that we are also in the process of launching the GeoAI Challenge, which aims to accelerate the democratization of the use of AI around the globe in the geospatial domain and engage participants from the private sector, academia, national and international organizations to solve problems of relevance for the SDG. And with this, let me give back the floor to our very nice avatar, Anna, and I'll see you all in the neural network.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the satisfaction survey, connect with interesting profiles, or speak one-on-one using the chat and video function. After the 30-minute networking session, we invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits and poster boards, and build your personalized AI for Good program. It was a pleasure learning with you today. See you at the next AI for Good.